Transportation engineering or transport engineering is the application of technology and scientific principles to the planning, functional design, operation and management of facilities for any mode of transportation in order to provide for the safe, efficient, rapid, comfortable, convenient, economical, and environmentally compatible movement of people and goods. It is a subdiscipline of civil engineering and of industrial engineering. Transportation engineering is a major component of the civil engineering and mechanical engineering disciplines, according to specialization of academic courses and main competencies of the involved territory. The importance of transportation engineering within the civil and industrial engineering profession can be judged by the number of divisions in ASCE that are directly related to transportation. There are 6 such divisions representing 1/3 of the total 18 technical divisions within the ASCE. The planning aspects of transportation engineering relate to urban planning, and involve technical forecasting decisions and political factors. Technical forecasting of passenger travel usually involves an urban transportation planning model, requiring the estimation of trip generation, trip distribution, mode choice, and route assignment. More sophisticated forecasting can include other aspects of traveler decisions, including auto ownership, trip chaining, and the choice of residential or business location. Passenger trips are the focus of transportation engineering because they often represent the peak of demand on any transportation system. A review of descriptions of the scope of various committees indicates that while facility planning and design continue to be the core of the transportation engineering field, such areas as operations planning, logistics, network analysis, financing, and policy analysis are also important to civil engineers, particularly to those working in highway and urban transportation. The National Council of Examiners for Engineering and Surveying list online the safety protocols, geometric design requirements, and signal timing. Transportation engineering, as practiced by civil engineers, primarily involves planning, design, construction, maintenance, and operation of transportation facilities. The facilities support air, highway, railroad, pipeline, water, and even space transportation. The design aspects of transportation engineering include the sizing of transportation facilities, determining the materials and thickness used in pavement, designing the geometry of the roadway. Before any planning occurs, the engineer must take what is known as an inventory of the area, or if it is appropriate, the previous system in place. This inventory or database must include information on population, land use, economic activity, transportation facilities and services, travel patterns and volumes, laws and ordinances, regional financial resources, community values and expectations. These inventories help the engineer create business models to complete accurate forecasts of the future conditions of the system. Review. Operations and management involve traffic engineering, so that vehicles move smoothly on the road or track. Older techniques include signs, signals, markings, and tolling. Newer technologies involve intelligent transportation systems, including advanced traveler information systems, advanced traffic control systems, and vehicle infrastructure integration. Human factors are an aspect of transportation engineering, particularly concerning driver-vehicle interface and user interface of road signs, signals, and markings. Highway engineering. Engineers in this specialization handle the planning, design, construction, and operation of highways, roads, and other vehicular facilities, as well as their related bicycle and pedestrian realms. Estimate the transportation needs of the public and then secure the funding for the project. Analyze locations of high traffic volumes and high collisions for safety and capacity. Use civil engineering principles to improve the transportation system. Utilizes the 3 design controls, which are the drivers, the vehicles, and the roadways themselves. Railroad engineering. Railway engineers handle the design, construction, and operation of railroads and mass transit systems that use a fixed guideway. Typical tasks would include determining horizontal and vertical alignment design, station location and design, and construction cost estimating. Railroad engineers can also move into the specialized field of train dispatching, which focuses on train movement control. Railway engineers also work to build a cleaner and safer transportation network by reinvesting and revitalizing the rail system to meet future demands. In the United States, railway engineers work with elected officials in Washington, D.C., on rail transportation issues to make sure that the rail system meets the country's transportation needs. Port and harbor engineering. Port and harbor engineers handle the design, construction, and operation of ports, harbors, canals, and other maritime facilities. This is not to be confused with marine engineering. Airport engineering. Airport engineers design and construct airports. Airport engineers must account for the impacts and demands of aircraft in the design of airport facilities. These engineers must use the analysis of predominant wind direction to determine runway orientation, determine the size of runway border and safety areas, different wingtip to wingtip clearances for all gates, and must designate the clear zones in the entire port. Professional societies. Young Professionals in Transportation. Institute of Transportation Engineers. American Society for Highway Engineering. American Society of Civil Engineers. American Planning Association, Transportation Planning Division. The American Association of State Highway and Transportation Officials. Eastern Asia Society for Transportation Studies.